I am Anil Kumar, and in a series of 5 videos, I'll explain you how to graph transformed sinusoidal functions. Now, this is the very first one. Normally, when we say transformed sinusoidal function, we write the equation in the form y equals to a times sine of k x minus p plus q, where a is the amplitude, k is number of waves in one cycle of 2 pi if you're doing in radians or 360 degrees. P is the phase shift and Q is vertical translation. In this particular video, we'll concentrate on the amplitude and the vertical translation. These will give you vertical transformations for any sinusoidal function, right? So when we talk about sinusoidal functions or the sine waves, we know this is a wave which is kind of like this. So let me sketch one here and then we'll discuss about it. So it's a periodic wave, right, as you can see here. So it's a periodic wave which has no restrictions on domain. So when we say it is a sine function, then we are trying to say that at 0 the value is 0, right? So let me consider one particular wave. So what we'll do is we'll draw an axis here. This is the axis, and when we say sine wave, at 0 it is 0 and it is rising. That is how we say or we recognize a sine wave, right? So what I will do is I'll draw y coordinate, like y axis like this. So that becomes my coordinate plane, where I have along the horizontal axis, in this case the angle is x, so I'll write x on this side and y is the y value which I'm writing there, correct? So for any particular sine wave, what you will always notice is that there is one wave which repeats. So let me highlight this particular wave. One wave starts with 0. So this is a wave which repeats. So this is one wave. So what we have written here is a sine x. Now in this particular wave, default values are at 0 the value is 0. Amplitude of this wave is 1, that is the maximum. Minimum is -1. Now one cycle, it takes 2 pi in radians or 360 degrees, right? So if you're working in degrees, 360 degrees. And then to identify the wave, we could have 5 points. These are the 5 points which we are going to consider. Okay. Now these points are 0, 1, 0, -1, 0. So let me make a table for you so that it helps us to, identify these points, remember them. Okay. So this is the kind of table which I'm going to use most of the time while discussing transformed sinusoidal functions, right? So we have 5 points here. Let me extend this a bit. Okay. So what I'm trying to say is that for a sine function, we'll consider these 5 points. That is to say, if I have an angle which is x here, right, then the value of the sine function, which is y, equals to sine x in this case. X I'm taking in degrees or in radians. Let me take this in degrees. So 0 degrees, and then 90 degrees, 180 degrees, 270 degrees, or 360 degrees. So these are the 5 points, and you'll find for sine the values are 0, 1, 0, -1, back to 0. So these are the points which we will be considering, correct? So in radians, 2 pi is your full cycle time period. Half of it is pi, then half of pi is pi by 2, and then 3 pi by 2. That is in radians, okay? So those of you who are working in radians could always write this as 0, pi by 2, right? So let me write this as let me write here itself. It could be 0, pi by 2, pi, 3 pi by 2, or 2 pi, correct? So that is in radians. So this is in degrees, you understand. And these are our default values. So 5 points. So always consider these 5 points. Remember, starting point is on the axis, so this is your axis. So we are calling this line as axis. And the equation of axis is y equals to 0 for us, correct? And this distance here is the amplitude, and this amplitude is reflected by the value a, which we are talking about, and this axis is represented by q. So these are the two things which we are going to consider in this particular video, right? So we'll consider vertical translations and see what happens to this sine wave as the value of amplitude a changes and as the value of q, the axis of the sine wave, changes. So let me write down a few examples here to help us out. So let me change a first. So a could be 2 sine x, for example, right? So, and then we could have a y equals to, let us say, half sine x. Now what happens if I do y equals to 2 sine x? In that case, this sine wave will basically be, so let me draw the axis x and y. So what really happens in this case is that the amplitude increases. So I'm drawing only one cycle. So the amplitude becomes not just 1, it becomes 2, that value. So this becomes minus 2. Axis here remains at x equals to 0. So this is the x value. If we have half as the equation, then the wave will be kind of flatter, right? It will be like this, where this point will be half, right? So, or minus half here. So that is for the half portion. Is that okay? So 2 means basically a, the amplitude, is getting multiplied by this factor. That is the effect of a. Now let us see the effect of q. So if I have an equation which is y equals to, let us say, 2 sine x minus 1. Sine x minus 1. In that case, what happens? In that case, really, the sine function, once it gets multiplied by 2, vertically stretched by a factor of 2, that is the first portion, which we saw here, minus 1 brings the whole graph 1 unit down. So that means this axis actually moves 1 unit down. Do you see that? So that is the effect of minus 1, right? Now, if you bring the whole unit 1 unit down, in that case, maximum value will not remain as 2, but it will become 1, right? So the wave which will have will be it'll go from here 2 units up and 2 down, right? So the minimum will be at minus 3 and the maximum will be at 1. So we'll have a wave which is kind of like this. Okay, so that is how the wave will end, correct? Where of course this will be one cycle, which will be 2 pi, and this point here is minus 1, and that is this value q, right? Maximum will be at 1, minimum will be minus 3. So if you have vertical transformations, you can find maximum and minimum using these two values. As you can see here, maximum is equals to q plus a, right? And let me write maximum or minimum, right? If it is minimum, it will be minus a. So q plus minus a actually gives you maximum minimum values. Is it okay? So how far you are from the axis, that is what a is, correct? At times you may have a as negative. For example, I could have a equals to minus half, minus, right, sine x, and let me write this time take sine x plus 1 as our example. So what really happens in this particular case? Now in this particular case, what really happens is, let me sketch here itself. Since it is minus, the wave gets reflected downwards. Do you see that? And that plus axis is moving 1 unit up. So in this case, what we do, we first sketch the axis, which is 1 unit up. So let us say this is 1 unit up, so that is the axis. So let me write down equation of the axis, which in our case will be y equals to 1, the q value. And then let's find what could be the maximum and minimum. So in this case, always amplitude is considered the absolute value, okay, half. So you could go half up and half down. So the wave is in between these two. So somewhere here will be a maximum, somewhere there will be a minimum. Negative means instead of going up, the wave starts like this, right? So the points will be like, will not go 0, 1, 0, minus 1, 0, but be 0, minus, will go towards the minus side, right? And these values are actually multiplied by a. So these values gets multiplied by a value. So in our case, a is half. So, well, you can say minus half. So these values get multiplied by minus half. So 0 remains 0. And 0 plus 1, that's why we went 1 unit up, right? And then minus. So the wave now will be kind of like this. You see that? So that is how you're going to draw the wave. So if it is minus, it gets reflected, right? So actually speaking, I should have drawn a wave first here. So first we'll draw the first portion, which is minus half sine x. So using our 5 points, which are 0, 1, 0, minus 1, 0, which are with a time period of 360 degrees or 2 pi, we could construct a wave. But these values, the amplitude or the y values, will get multiplied by a, right? In our case, a is half, so minus half rather. So when you multiply these by minus half, you actually get a wave which is kind of like this, right? So that is the first step. And the second step is to move it upwards, plus 1. Then you move it upwards and you get your final equation. So that is how you should be drawing sine waves when vertical transformations are being performed. So what we can summarize here, so whenever you do transformed sinusoidal function, first step should be to sketch graph with vertical stretch or compression. I should say or reflection, right? So the value of A. So in this 5 points, you should multiply them with A to get your values. Then you sketch your graph. And the second step is to translate vertically. Now you could translate vertically. So this translation of vertical translation is because of Q, right? So this is because of Q. If it is plus, it is up, minus means down. And vertical stretch compression is because of A, correct? So that is the key value. Now let's summarize here what happens with A. So if A is positive, in that case the graph of sinusoidal function moves up. If A is negative, it moves downwards. If A is greater than 1, then it's vertically stretched. If it is less than 1, the absolute value, then it is compressed, as we saw in these cases, correct? So if absolute value of A is greater than 1, in that case it is stretch. But if absolute value of A is less than 1, then it is compressed. And if A is less than 0, then it is reflected, right, on x-axis. So in short, these are the things which you have to keep in mind to sketch a sinusoidal function, right? So